Alright, let's try and take a look at this problem. We have Daphne is swimming 60 laps and she's doing it in 41.5 minutes. And Mary is swimming 60 laps, but it's taken her 42.5 minutes according to the graph. I'm getting that from on this graph that's in the problem. I found the problem in 10 marks, and on this graph right here you can see that in 60 laps it takes Mary, this is Mary's graph, 42.5 minutes. You can tell that by this point right there. So now I have that data, and I've tried to replicate that data on the graph in front of you. It's hard because the times are so close to each other, but I put a point up here to represent 41.5 minutes, and almost right next to it 42.5 minutes. So Daphne's graph would end up looking like something like this. And we have Mary's graph would look something like, let's get another line in here. Mary's graph would look like this. It would go very close to her, Daphne's graph, but it would be a little bit lower. Now let's interpret this graphically. First of all, for any given amount of time, you can see that Daphne's line, D, is going to be a little bit higher than Mary's. So Daphne is actually swimming for any given time. Daphne is actually swimming more laps than Mary is swimming. So if I go up, this is 30 minutes. So if I go up 30 minutes, Daphne is swimming that much. And if I go up 30 minutes until I get to Mary's line, Mary has swam that many laps. So in 30 minutes, Daphne is swimming more than Mary is. Let's look at it from a ratio standpoint. If I look at Daphne's ratio of minutes of laps per minute, if I look at it as 60 laps in 41.5 minutes versus Mary, and Mary is at 60 laps in 42.5 minutes, I see that Daphne's number is actually bigger because the denominator is smaller. So let's look at it from a unit rate standpoint. I think I calculated it out, and Daphne is covering about 60 divided by 41.5 is equal to 1.44 laps per minute. And this turns out to be about 1.41 laps per minute. So you can see that Daphne is covering more laps per minute than Mary is covering, and that is shown by the graph also by the fact that Daphne's slope is higher. Daphne's line gets higher faster than Mary's line does because she has more laps for every minute that we go up. So for every minute that we go up in this direction, Daphne's line is going up 1.44, and for every minute we go up, Mary's line is only going up 1.41 laps. So if we take a look at the questions we're being asked, it states that Mary is wrong because the slope. Mary believes that she can complete 180 laps faster. Mary is wrong because the slope of the line representing Daphne's description. Sorry, we were interrupted. Mary believes that she can complete 180 laps faster than Daphne. Mary's wrong because the slope of the line representing Daphne's description is lower than the slope of the line Mary's graph. That's false. That is not true. We saw that Daphne's line is higher than Mary's because she is increasing in the number of laps she's covering at a different. Next, Mary is right because the slope of the line representing Daphne's description is higher. Well, first of all, it is higher, but that does not indicate that Mary can swim any faster than Daphne can. So that would be false also. Mary is right because to complete one lap, Daphne takes more time than Mary takes. That's not true. Daphne actually takes less time than Mary takes. Mary is wrong because to complete one lap, Daphne takes less time than Mary takes, and that would be true. I think I've covered this problem. Take a look at it and get back to